Hey guys, today you're going to be on page 4 in your packet. So remember, if you need to find your packet, you can go back to Google Classroom and you can look at whichever section you're in. I'll just do 8th period, for example. Go to classwork, scroll down to motion and forces, and it is right here. All right? So we're going to be looking at page 4 of that packet. So you should turn to page 4 and you should fill in the blanks. You may need to pause it because I may go quicker than you need it, but you can pause it and fill in the blanks. So velocity includes the speed of an object and its direction. So our speed yesterday was distance over time, so 55 miles an hour. When we put in the direction like south, north, east, or west, we have our velocity. So velocity of an object can change even if the speed remains constant. Because if you're going 55 miles per hour north, you're going a different velocity than 55 miles per hour south. So, even if the speed is constant, the velocity can change because our direction changes. Now, when our velocity changes, what happens is acceleration, the rate of change of velocity. So when velocity changes, the object is accelerating, even if it's only changing directions. So it occurs when an object speeds up, its direction, or both change. So if we speed up, slow down, or change directions, we are accelerating. That means if you're going around and around on a race car track, you are accelerating because you're constantly changing directions, even if you've got it on cruise control. Okay, positive acceleration, this is pretty self-explanatory. It means you are increasing speed. Negative acceleration means you are decreasing speed. If you are slowing down, you're decreasing your speed, you're negative. If you're speeding up, you're positive. So that should be the case when we calculate acceleration. We are going to do final velocity, which means your ending velocity, minus starting velocity over time. Okay, and I'm going to write that down for us. Be sure you write down ending velocity minus starting velocity over time. Okay, so let's look at an example. Now, like I said, you may need to pause this and write yours down, but it says that we are traveling at a speed of 10 meters per second. That means when we start, we are traveling at 10 meters per second. That is our starting velocity, initial velocity. 5 seconds later, we are going 30. That's our ending velocity, our V final. So our V initial is 10, our V final is 30. Remember, V final goes first. 30 minus 10 divided by the time, 5. 30 minus 10 is 20, divided by 5 equals 4 meters per second squared. Okay, so when you are doing your acceleration, it will not just be like speed, meters per second, it'll be meters per second squared. All right? Now, let's practice it. Pete the penguin is going to sled down his favorite hill. He hits a speed of 50. That means he ends at 50. After 5 seconds, what is his rate of acceleration? So it doesn't tell us where we started. So I'm going to assume it's 0. I know he gets up to 50. So his final is 50. His initial is 0. It took 5 seconds. 50 divided by 5 is 10 meters per second squared. Okay. Mike's truck decelerates, meaning it's slowing down. So remember, if we are slowing down, we're going to be negative acceleration. He slows down from 72 to 0. So he ends at 0. He ends up stopped. So our final is 0. Her initial is 72. 0 minus 72 over the time it took 6 seconds. So don't get confused. When you are subtracting 0 minus 72, you should have a negative number. Negative 72 divided by 6 gives you negative 12 meters per second squared. Remember, it's negative because he is slowing down. So if you look at the next exercise on page 5, there are 5 problems. All right, a skydiver falls from an airplane and achieves a speed of 98 meters per second after 10 seconds. The starting speed is 0. So our final is 98 meters per second minus our initial 0 meters per second divided by the time, 10 seconds, equals what? Well, we know that 98 divided by 10 equals 9.8 meters per second squared. Okay, so be sure you have the squared out there. A 50-car train going 25 meters per second takes 150 seconds to stop. It is stopping. So its final is 0, its initial is 25, divided by 150 seconds. So negative 25 divided by 150 gives you negative 0.17. Okay? A Boeing 757 was flying at 150. That's its starting, V initial. And then it slows to 110. So it's slowing down. That's V final. Okay? And it takes 10 minutes. Time is given in minutes, so converts minutes to seconds. We know 10 minutes is 600 seconds. So I'm going to put 600 seconds on the bottom. V final is 110 minus V initial, 150, gives me 110 minus 150 is negative 40 divided by 600, which gives me negative 0.07. Okay, a runner speeds up, and remember it's negative because it says we're slowing down. Speeds up from 4, V initial, to 6, V final. So 6 minus 4 divided by 10 equals, final minus initial, so it's not going to be negative. It's going to be 2 over 10, which 2 divided by 10 is going to give you 0.2. Okay, a car traveling at 24 meters per second comes to a stop. So V initial is 24, stop is V final. So if stop is V final, that means it's 0 is V final. V initial is 24 divided by 8. So we're slowing down, so it's going to be negative 24 divided by 8. And that's going to give us negative 3. Okay? So now we're going to calculate that in the same way, just using a graph. Okay, so you can see your graph up here. Okay, I'm going to zoom in on it just a little bit so you can see. So it gives you your velocity and your time. So all we're going to do is read the graph in order to get it. So it says, number 1 at the bottom says, right here, it says calculate the acceleration of the car between 0 and 20 seconds. Well, at 0, it's 0. So my V initial would be 0. 20 seconds would be 10. So my V final would be 10. So I've got 10 minus my initial starting at 0 over, and it says 0 to 20 seconds, so that would be 20 seconds. 10 over 20 is 0.5. All right, it says at 25 seconds, what is the car acceleration? So right here, we see the velocity is not changing right on this flat line, so the acceleration is 0. Okay, and then they want the acceleration between 30 and 60 seconds. So you'll notice between 30 and 60, the line is going down, right? So that means it's going to be a negative acceleration. So our final velocity at 60 is going to be 0. Our initial is going to be 10. So our final minus our initial over the time it took, between 30 and 60 seconds, is 30 seconds. Negative 10 over 30 is negative 0.3. So it says at 45 seconds, what is the car's speed? So remember, speed is distance over time. 45 seconds right here. I'd have distance over time, but my speed right here, velocity, remember velocity and speed are the same thing, so I can just use 5 meters per second. Now, the last thing that you are going to do is page 7 and 8. Now, 7 and 8, and I get that you could probably see these answers. That is the point. I want you to go through these questions, read them, and see what you choose as your answer. All right? You've got, don't do number 10, but you've got 1 through 9. And then flip it over, you've got 11 through 18. Okay? And you have to use your triangle. If you don't put your triangle down, I'm not grading it. Okay? So complete those, and then you will be done for today. Have a great day.